Thank you for joining today's Analytics for Living session on children's preventable diseases with vaccines using artificial intelligence with focus on pneumococcal. I'm James Mansfield from Analytics for Living. Great. So our objective, did I skip a slide? No, okay. Objective today is review and discuss how machine learning, artificial intelligence helps diagnose, estimate value, and measure children's preventable diseases with focus on pneumococcal disease, right? So we're gonna go through an introduction, talk about children's vaccines, preventable diseases, and then how we're applying machine learning and artificial intelligence to meet those needs. So first, I'll give a disclosure though. The views today that I present are the views of myself and not from any other current or prior client or company that I have worked. So perfect. Now that we got that out of the way, let's get started here. So again, James Mansfield, leading Analytics for Living, where we apply machine learning or AI to improve health, innovative technology growth, and financial sustainability. I also am a consultant with Data Prime, helping them expand their footprint into the life science. And then I have 25 years of life science experience, also consumer packaged goods, financial services, most recently with Merck, and then with GSK. Not on the line today, but in spirit is Tyler Smith. Tyler Smith is the leader of talent acquisition at Data Prime. She has 20 years of experience, both with the government, Comcast, Amazon. Happy to be part of her. The intent of why we partner with Data Prime is that, if we deliver, to a client, or we need to really expand a project to as well, when we need talent or staff, right? We partner with Data Prime, who uses AI technology, actually go and find talent so that we can, put that talent forth as well. So let's have a base case, and then I'm going to run through these slides really quickly here. And I encourage you, if you wanted more of a drill down on children's vaccines, we have two separate sessions, I'd say, on to attend. One is on children's vaccines, just looking at those in total, right? This is on pneumococcal, right? And then another session of trying to, vaccinate 200 million children that are unvaccinated today. So, but let's get the base case on kind of what's recommended, and I'll go through this real quickly here. Okay, so what's recommended, and again, we're focused on pneumococcal here. What's recommended is there's roughly about 20 different vaccines that are recommended, right? So if we go down here, there's a significant list that's on here. So pneumococcal is on the list too as well. So as you go through and kind of look through the list, right, there's a variety of different recommended vaccines that are here. Pneumococcal is obviously one of these of a suite. The World Health Organization put those out. Depending on the country is where you would get those, right? So typically, children would get that. Also adults over 50, right? But we're really focused on the kids in this point here, or children, right? Why are vaccines important? Well, pre-COVID, they prevent roughly 4 to 5 million tests per year. And unfortunately, a lot of the vaccine programs are suspended due to COVID, but that's kind of the background here. So why we're focusing on, preventing children's diseases, and the problem statement, and we're going to focus on pneumococcal too as well, but just kind of have the big picture. I thought it's helpful to kind of see where pneumococcal fits in as well. So right now today, there's roughly about 228 million, mostly children, at risk for diseases, right? And this is kind of the base case of where we are today. And I think it's helpful to understand this so you can kind of put in the context of pneumococcal as well. So and why it's so big or you may not have a context, right? So let me give you a little context in this. So the way to read this table here is that there's children that are un or under vaccinated, children that are un or under vaccinated, right? So net, they did not get their vaccine. And some of the reasons why could be, right, the vaccine programs were disrupted, or the country, or something was going on in a country, right? Maybe there's an earthquake, maybe there's something else. And then UNICEF typically delivers those vaccines, and they typically deliver about almost 230 billion vaccines, right? So in 2019, pre-COVID, there are roughly about 20 million children annually that typically do not get a vaccine, right? That's a big problem too, I get it, right? But there may be other issues, right? That maybe over the years it's been consistently 20 million. Everyone's happy about that. I'm not happy about it, but but that's kind of the number there, right? And then typically the reason why that is that the vaccine programs that's disrupted. So UNICEF or whoever, or the government, can't deliver the vaccine. So net there's these children, 20 million that aren't. COVID, unfortunately, kind of disrupted a lot of these programs, right? Vaccines programs. So if we look at 2020, there were 80 million kids. Fast forward, because it's a whole nother year, right? And more births, right? Where someone needed to get vaccinated, right? And now we're at 200 million, right? So we'd have roughly 50 to 75%, and now 37 to 50% of all those, countries' programs that were disrupted, and that you have children that were not vaccinated. If you look at 2019, really 27 countries just with MMR really didn't vaccinate any kids for that, right? And then also in 2021, now 50 countries, right? Pneumococcal, I'll get there, is one of these, right? That's in the suite of these, but the big picture is, right, there were 280 vaccines sitting in a warehouse here that didn't go out to 228 million children. Big problem. So pneumococcal is important. I'm going to switch gears on this, right? So just back on this. If you're interested in this, recommend there's two presentations or two sessions. One on children's vaccines, second one on the 200 million, right? This 200 million number, and ways to address that. Okay, so pneumococcal disease, right? What's the problem or what's the opportunity, right? So it's right at the top here. The opportunity to vaccinate, right, and understand pneumococcal, right, is a curable, virus, right? There's a vaccine out there, right? So you can get the vaccine, and you don't get pneumococcal, right? Okay, but and there's still an opportunity here to vaccinate, newborn children for pneumococcal, and it would save roughly 26, almost 27 million children's lives per year, 1 year, right? If you look at the births per year, if these kids got it, 26 million wouldn't die, right? If they didn't get it, it's going to happen, 27 million, right? That's kind of, net right on that. And it would decrease 336,000 hospitalizations, right? That's a single cost and a challenge for everyone, right? A little bit about, it's a big opportunity. What is pneumococcal? Well, it's a range of serious diseases such as like meningitis. So you get in the lungs, and then you get in your spine, right? In your and the nerves. So you get meningitis and you get pneumonia, right? And then when you have that, then you're hospitalized, and it's devastating, right? Of course, right? And it could be, for some, it's just maybe milder infections or sinusitis ear infections, but how it's identified is a patient walks in the hospital saying, "Oh my goodness, I'm paralyzed," or "I can't breathe," and it's not going away, right? Oh, pneumococcal, right? So you typically see, well, 10,000, about 10,000 infections. This would be 10,000 infected. 24 would go to the hospital, right? And 8 of those, right? 8% of those would die, right? So I say, oh, the numbers look small, 24. No, it's not, right? When we project that out, right, it's 27 million, almost 27 million children dying each year, right? Almost 336,000, right? The 24 to 10,000 is 336,000 children hospitalized, right? It's a big problem. So, and it's a preventable disease, right? So that's kind of the one point we're here. So what can you do on this, right? So, the approach that we have laid out is that data exists for pneumococcal. Actually, we know where it has been distributed the past number of years, and we know where it's not, right? And we have all the other vaccine data that kind of mirror against it, right? So this first piece is the vaccine data. We could say, okay, here's where it's not happening, here's where it is happening, or here's where it's happening at a level, but it should be much higher because we know what the birth rate is, right? And then the other data is the vaccines, right? The record data is there as well. And then also the supply chain data is there. And I'll share an illustrated example of kind of what that looks like, on the next, 2 or 3 sides, right? One of the other components, I think, if we're going to say, hey, let's do a push for pneumococcal, would be COVID, right? Because it's in our world right now, right? We have to kind of address that. So you don't want to stand up a pneumococcal clinic where they're going to have another wave, right? Because that's then what happens to pneumococcal that's in the country, you can't get it out, it could expire, right? So forth, right? There's a lot of issues on that. So that's why I think part of the modeling has to be COVID. And the last part is where machine learning AI comes in. Key for this, right? If you have all this data, how do you parse it all out and say, here's where I should go, right? Versus this where I should go, right? And run simulation. That's why our AI and machine learning technology is fantastic for this business problem, right? And patient problem and health problem, right? To solve for here. So that's the data that we have, the approach, right? Where to start, right? For pneumococcal, we can identify the lives, right? I did already, right? I can now identify the countries and regions and so forth. So it's definitely something that's key that we can go in. So here's an illustrative example of what it could like, right? And we look at the left, and I'm just modeling, not pneumococcal here, I'm modeling all those vaccines, right? All the vaccines, we're able to say in 2019, here's where they didn't get it, right? Here's where they didn't get it, right? I took all that, the latest data, ran the model, put all the things in and say, here's where most of the vaccination programs are not happening. So most of the pneumococcal is not happening in these places because it's just not getting out there, right? There may be other countries here in the white that maybe they don't pay for pneumococcal vaccine for children, right, too, as well. I didn't kind of incorporate that, but it's something we could look at, right? But certainly in this case, we have a whole region, right? Region in Africa and Latin America, Central America, and Mexico, right? They're, definitely key places to implement that, right? So our proposal is to use, the vaccination child problem state for pneumococcal, right? Use that data analytics, employ the machine learning AI to kind of solve that problem, and then say, hey, where's the priority countries this week, right? Because of COVID. Next week it may change. Next week it may change, right? But we really feel we can do a good job on COVID prediction up to 60 days, right? And it doesn't take that long to stand it up, right? The infrastructure is already there. You have it sitting in wherever, right? Okay, hey, here's where you can do the vaccine in the next 60 days, right? Boom, let's move, right? Think about rapid response, right? It's something that's possible that can be done. I attended a presentation in Forms, and there's all about things about drones, like drones flying in, dropping in medicines, right? I mean, it's possible, right? Technology's there. Let's do it. Okay, cool. So our recommendation is, right, to vaccinate all the kids right here, but kind of work with the World Health Organization, UNICEF, and also engage pharmaceutical leaders, and then publish this as a consortium, right, to say, hey, here's pneumococcal, right? Here's where the kids that are not getting it are, so that it kind of does a push and pull in some of the countries to open up and kind of do those things, right? So last thing, and then we'll close out here, is analytics for living. Our vision is really to enable analytics for life, right? Our mission is to improve access to life, improve access to life-saving medication, life-saving innovations, right, for populations in need. We employ machine learning and AI in this space. We are a foundation, right, and we have a corporation. We have both, right, so that we can support both if it's kind of outside of the scope of our or it needs to scale outside of the scope of kind of our mission, right, for what we're trying to do. But we have we take donations from physical officers, anything within vaccines, pretty much anything in healthcare, right, is within our kind of initiatives there. So, but in this case, if it was pneumococcal, right, it's one of our physical sponsorships, so we can give you access to this data, right, is kind of a learning to kind of see how to go. And then if you're interested in moving forward, then we can kind of partner with you to kind of implement a plan to execute. And Data Prime, as I mentioned, there supports talent. So say you wanted to kind of implement and scale this, well, we have Data Prime, and you're in whatever country it is, you're saying, I don't have a data scientist, or well, that's where Data Prime comes in. We can help find someone to put there and help and drive it. So perfect. So thank you for today. I appreciate it. Don't miss the other vaccine programs I mentioned. And then also additionally, we have other series on mental health and a few other topics. So I welcome you to kind of take a peek at those. Thank you very much.